Practice number 5. I love this problem. This is the crown jewel of chapter 7. What we're going to see in practice number 5, maybe you read it already, has to do with production in a factory. This is real statistics, real central limit theorem that happens every day in factories around the world. What we're going to see here. And what's really interesting, like a statistician could come in, do the work that we're about to do, and then the people who work there in the factory, like the management of the factory that produces some kind of product, all they got to do is have their machines checked once in a while, and they'll know when to stop production to recalibrate. Okay, so let's go ahead and read this together. A factory produces chocolate bars claiming to be 1.55 ounces. So that's what they put on the package. That's actually what a Hershey bar weighs. We're not claiming these are Hershey bars. The manager of the factory knows that the actual weights are normally distributed. Okay, so the guy who runs it or the lady who runs it, they know that even though they put 1.55 ounces on the label, that might not be accurate every single time. So actually, the weights of the chocolate are normally distributed. The mean is 1.55 ounces, but there's a standard deviation of 0.02 ounces. Okay, well, that makes sense so far, right? Each morning, they weigh a carton of 20 bars. Or yeah, they weigh these 20 bars. The manager has ordered that production be stopped for the day if the contents weigh less than 30.8 ounces or if they weigh more than 31.2 ounces. If it's less than 30.8 or more than 31.2 for the 20 bars, then they know that something is off. They need to recalibrate their machines to get the correct amount of chocolate in each bar. Okay, so let's go ahead and fill out these numbers here to start. So we've done this a few times now, right? The mean here is the 1.55. The standard deviation, the 0.02. What is n? And well, there's a few other numbers that we've read, but n, they say each morning a carton of 20 bars is weighed. So they're taking a sample of 20. Okay. Okay. So that leaves us with x bar to figure out, right, the sample average. Okay, so it turns out there's going to be two ways to think of x bar. Okay. There's the lower sample mean. That will give us one value of x bar. And there's the upper sample mean. That will give us a different value. So when they come in, they weigh the 20 bars. Let's look at the lower. So if it weighs less than 30.8 ounces, these 20 bars, if they come in and the weight, let's say, what if the weight of the 20 bars is exactly 30.8 ounces? Then what is the sample average? You say, well, you would take the 30.8, but that's 20 bars, right? So we need to divide that by the 20 to get the average weight in those 20 bars. So they don't tell us this directly. We got to figure that out. It turns out it's 1.54. Okay, so if we weigh this carton of 20 and it turns out to be this, that means the average of each bar in that sample was 1.54 ounces. Just slightly less than what it should be, but I guess that's off by enough that raises concerns. Okay, how about the upper sample mean? We're going to do the same thing, but now for the bigger number. There's a problem if it gets up to 31.2 ounces, but of course that's 20 bars, so we have to divide by 20 to get that sample mean. What's going to happen here? Oh, okay, 1.56. So again, they don't tell us that directly, but we can pretty quickly compute that if we know what we're looking for. And it makes sense, right? So if it's 0.01 too low or 0.01 too high on average, they know that something is off with their machinery. They need to stop production and go ahead and recalibrate something and get it back going maybe the next day. Okay. So what are we going to do? We need a probability based on all this stuff. At this point, the problem's going to look very much like problem number 4 in the last video. We've got all this information, part B, I should say. We've got these two X bars. We need to find the probability that X bar falls between. Now, it turns out this probability is not going to be the final answer, but it's going to be really useful in getting there. Okay, so what are the chances that X bar falls between those? Well, let's find the z-scores that go with each. And I'm just going to show you these one at a time. Okay, so if we start with the lower sample mean, that's our X bar. We've got our mu, we've got our sigma, we've got our sample of 20. Boom, boom. The z-score that goes along with X bar equals 1.54 is negative 2.24. Okay, so we will look that up in a moment. Let's go ahead and get the z-score for the upper X bar. Same idea. It's just now 1.56. Hey, wait a second. That just makes our numerator a positive compared to what it was. Well, maybe that's not surprising after all. You know, it's symmetrical around the ideal of 1.55 ounces. So we just happen to get the positive version of the z-score since it's all symmetrical. Okay, so we need to calculate the probability that z falls between these two. Again, just like the previous problem for part B. So if capital Z falls between negative 2.24 and positive 2.24, we'll take it less than the larger one, subtract, and the probability that Z is less than the smaller one. Okay, it's a lot to write, but hopefully you've got a good feel for how these play out after doing these several times. Okay, if you've got your table, I'm going to look up 2.24. For Z less than 2.24, I got 0.9875. 9875, yeah. And for negative 2.24, let me flip my page over. I got 0.0125. Okay, very nice. We've used our table, and if we subtract, we got 0.9750. I said a moment ago, this is not the final answer. Why is that? Because if Z falls between these, or in other words, if X falls between there, then that means everything is good. We're okay if X bar falls between here, right? That means production is as it should be. This is the probability that the factory will continue production for that day. Makes sense. Chances are pretty high that everything's calibrated correctly and they can start producing chocolate for the day. But now, what was the question? I don't think I ever even read it back at the beginning. It's talking about having to stop production, and we'll get to the fact that it's 200 days at the very end. But kind of in the end, like we need the probability that production gets stopped. Well, if this is the probability that production continues, how are we going to find the probability that they stop production? Well, the probability that the factory stops production, well, it's just going to be the complement, right? We'll take 100% 1 and subtract the probability that they are going to continue, and there's the chances that they have to stop production for the day, 0.025, 2.5%. Okay, so there's some complements happening in different ways here, and the upper X bar and the lower X bar stuff, a lot going on in this problem. But it is all things that we've seen. They're just now all colliding at once. Okay, so if this is the probability that they stop production, then what's the deal with this 200 days? So it says if the factory operates for 200 days of the year, on how many days does the manager stop production? Well, if this is the chances that they stop production and there's 200 days, then we're just going to multiply 200 times that probability. They have to stop production for 5 of those days. Or I guess that's what we would predict, right? Who knows the reality, but it's probably going to be something pretty close to 5, if not exactly 5. And that's our problem. Pretty cool. Hey, 200 days, they only have to stop and recalibrate their machines on 5 of those days, right? That's pretty good. That's pretty good. Like I said, I mean, this is how factories operate. They'll call in statisticians. They'll weigh all of, maybe several hundred or several thousand chocolate bars every so often, and find out what the average is and the standard deviation. And statistician can sit down for a few minutes, right, and do these calculations, and then get back to them. Hey, if you're comfortable with your average chocolate bar being 0.01 off of what you're claiming, then this is what you can expect. You can expect to have to shut down 5 days out of the year. But all they gotta actually tell them is, hey, just have somebody weigh a carton of say 20, and if it's less than that or if it's bigger than that, then you got a problem. And there you go. Okay, that does it for chapter 7. Good luck in the homework. Bring your questions to our live session. See you then.